So what we're going to talk about today is chemical bonding and the two main types of chemical bonds. Okay, and I'm sure many of you have heard of these types of chemical bonds before, which is great, but we'll talk about them a little bit today. So chemical bonding occurs when atoms either exchange or share electrons. And the electrons that they're exchanging or sharing are those valence electrons. Okay, they're those valence electrons. Now, there are two types of bonding, two general types of bonding. However, there's lots more nuances to them. But the overall two general types of bonding are covalent and ionic. Easy to remember, covalent, you cooperate, and you share electrons. So nice. So nice of each other to share. And then the other type of bonding is ionic bonding. So in ionic bonding, one atom gives and one atom takes electrons. Now, I'm sure you all have heard of this before in some way, shape, or form, ionic and covalent bonding. I'll tell you that it's a little bit of a fib because really all bonding is the exchange or sharing of electrons, and it's just the extent to which they exchange or share electrons which determines whether they have more what we say ionic character or covalent character. It's more of a sliding scale, Some molecules are very polar, where they don't share electrons very evenly, so they're almost like ionic bonds. Okay, it's kind of like I said, a sliding scale. It's not black and white. It's not a hard line. There's not a hard line between ionic and covalent bonds. It's pretty gray. There's something called electronegativity, which is an atom's ability to pull electron density towards itself. That really determines whether something is ionic or covalent. Okay, but we're just going to stick to these general ideas here. I'm just throwing out some information for you guys. I'm just talking about it. It's not required that you actually really need to know it for a test or quiz. I'm just kind of telling you that, there's chemistry really is not black and white a lot. It's very gray. There's a lot of uncertainty to it. There's a lot of nuances to it. You really have to understand the concepts to really understand the chemistry behind a lot of things. Okay, but as we teach it at the lower, like the early levels, not I don't say the lower levels, but early on when you first learn about it, you learn about it more like black and white, and then as you get going, it just gets fuzzier and fuzzier. And even when you get to college, you get to really fuzzy things. Like they don't really make much sense, but we'll get there. Anyway, so let's move on here. Okay, so ionic versus covalent, what is the difference? Well, basically both of them are holding atoms together. Okay, but in an ionic bond, what holds them together is the fact that one's positive, one's negative. So we have an exchanging of electrons. So exchange electrons, but then what holds them together is that the fact that they're oppositely charged, a positive and negative charge. Right? So we know that opposites attract, right? Opposite charges attract. So what holds ionic bonds together is the fact that they're oppositely charged. Covalent bonds, on the other hand, they're held together because they share the electrons. So both of them are pulling on the electrons, and as they both pull and try and pull the electrons towards themselves, they wind up sticking together. Okay, so they're both pulling on those electrons, and now they're sticking together. If you really think about it, though, if this is negatively charged, like an ionic bond, one's negative, one's positive, this positive charge, what negative charge is it holding on to? Well, it's holding on to those electrons. So, like I said, it's kind of a gray area here, right? This positive is still holding on to these electrons. So, in a sense, they are still kind of sharing them, but it's just that one atom holds them really close to itself. Whereas in covalent bonds, the electrons are shared more equally in between them. I always think like ionic, I'm selfish. I'm selfish. I either want to take the electrons or I want to give them away. Whereas covalent, we cooperate when we share electrons. Okay. Now we're going to talk a little bit about their properties. Ionic bonds in general, ionic bonds, ionic compounds, they form these crystal lattice structures. So when you see like lithium chloride, LiCl, or sodium chloride, table salt, NaCl, that doesn't mean that there's just one sodium atom and one chlorine atom together. What it means is that it's just the ratio. There's one sodium for every one chlorine. And then they form this crystal lattice structure. Okay, so the negative ions and the positive ions kind of form this regularly repeating pattern. Okay, they form a regularly repeating pattern. They form these really, really large molecules, basically. And there's all different types of crystal lattice structure. There's all different types of crystal lattice structures. That all really depend on the size of the ions and the charge on the ions. And each ionic structure, each ionic substance will have different crystal lattice structures. Some have the same, but often they're different. And any really ionic compound, an ionic compound is often referred to as a salt. So when you hear table salt, that means sodium chloride, but really like lithium chloride is considered a salt as well. Lithium chloride is salt. Calcium chloride is a salt. Magnesium chloride is a salt. Magnesium fluoride is a salt. So a lot of these things are just salts, but we only refer to table salt as salt in common terms, that is. For covalent bonds, they form molecules. So they can form simple molecules like H2O, where it's just two hydrogens and one oxygen molecule. Those are just simple molecules. Or they can form really, really big, complicated molecules. We'll talk about that a little bit later, but now properties of covalent compounds. So usually, now again, there's so many covalent compounds out there. I mean, there's thousands and billions of covalent compounds. But in general, if we have simple covalent compounds, small ones like CO2, H2O, carbon dioxide, water, or dihydrogen monoxide. Then we also have like all these are different sugars. Fructose, glucose, lactose, maltose, sucrose. These are all sugars. We always say like, oh, how much sugar does something have in it? Well, it could be any of these types of sugars. They're all sugars. Okay. Typically, though, they are either a liquid or gas at room temperature. Obviously, think about sugar. Sugar is a solid, right? CO2 is a gas. Water is a liquid. So many different properties. That's kind of why I put them here. They're just like crazy. But usually they have low melting points and low melting points. Even sugar has a pretty low melting point. It doesn't take much to heat it up and melt it compared to an ionic compound. If they are solids, they're relatively soft. But again, like wood is a covalent compound. Wood is not soft. It doesn't melt, actually, it burns. So these are just general things. They're not true for every compound. Usually, covalent compounds are insoluble in water. However, we do have ones that do dissolve, such as like sugar. Sugar dissolves in water. Ethanol dissolves in water. It's alcohol. Alcohol is a covalent compound. Okay, but a lot of covalent compounds do not dissolve in water. What it really depends on is how much how similar they are to water. If they're very similar to water, they dissolve in water. If they're not very similar, then they don't dissolve in water. However, pretty much all covalent compounds, this is pretty much true for all covalent compounds, they do not conduct electricity when it dissolved in water. Usually covalent compounds in general do not conduct electricity. This one's actually pretty true across the board. Okay, covalent compounds do not have free electrons. Their electrons aren't free to move around, so they will not conduct electricity. Even like sugar in water, sugar does not conduct electricity in water. Okay, so that's covalent compounds. Their properties. Some other things about covalent compounds. Covalent compounds are always made of two or more nonmetals. So covalent compounds are always made of nonmetals. So if you see nonmetals and only nonmetals, think covalent. As soon as you see a metal, you know it's going to be ionic or metallic. We're not even going to talk about metallic bonds right now. But. Okay, so in covalent bonds, nonmetals share electrons. Their electron clouds or their orbitals, remember we talked about how electrons are in orbitals, they overlap with one another. And technically, the electrons actually reside in multiple atoms. Okay, so this is a good picture here of how the electron clouds kind of overlap with one another, and the electrons essentially are part of both atoms. So that's covalent. That's covalent. Again, there's so many covalent compounds. The properties are really very, very wide ranging. Okay. Now let's talk about ionic. Ionic, again, like I said, ionic, they are crystal lattice structures. So like sodium chloride is salt, like table salt. This is a structure for that. And this is calcium chloride. So calcium, there's one calcium for every two chlorines. So there's twice as much chlorine as calcium in a calcium chloride crystal lattice structure. And these are all different pictures of salts. Usually the brown ones are iron. This blue one is probably copper. And then I'm not sure what this green and this light blue one are. I'm not sure what those are, and I'm not sure what this white one is. Not sure. Okay. And ionic compounds, they're usually solids at room temperature. They're pretty much always solids at room temperature. Ionic compounds, I think, are a little bit more consistent with their properties. Okay, they really just form these crystal lattice structures, and they are then usually solids at room temperature, pretty much always solids at room temperature. Can't really think of any ones that aren't. They're hard and brittle, like just think about any salt that you know of, right? Hard and brittle, easily cracked. And they don't melt that easily. It takes a lot of energy to melt them, and even more energy to boil them. It takes a lot of energy to melt or boil them. Now, salts are generally soluble in water, or ionic compounds are generally soluble in water. However, there are plenty of insoluble salts that do not dissolve in water very readily. There's plenty of them that do not dissolve 100%. Okay. When they do dissolve in water, so when they dissolve in water, they dissociate into ions. So you get positive ions and negative ions in solution. Now, because you have charged particles in solution, it makes it able to conduct electricity. Now, a salt itself, a solid salt, will not conduct electricity. However, if you melt it or you put it in water, it will conduct electricity. Those ions need to be free. In the crystal lattice structure, they are not free to move, but in water or when you melt them, then the ions are free to move and they can conduct electricity. And we call substances that conduct electricity when placed in water, we call those electrolytes. So I'm sure you've heard that term before for energy drinks when they're like, it has electrolytes. That's true, it does. So like magnesium, calcium, sodium, potassium, Gatorade, yep. Yeah. I think there's 5 of them. I think I know 4 of them: potassium, magnesium, sodium, calcium. I think there's one more. Can't remember off the top of my head, but those are the general electrolytes that they're talking about that your body uses for different processes and that your body will lose as you sweat. Yeah. But really what they're referring to and why they're called electrolytes is because they conduct electricity in water. Just so happens that your body also needs them. And your body actually uses them for a very similar process of moving positive and negative ions through different processes in your body. I don't know if you ever heard of like the sodium potassium pump in your heart. There's different processes in your body that require opposite charges to be placed on one side of the membrane so that they can move things from one side to the other. That's biology, though. Talk about that next year. Maybe we'll talk about it a little bit this year. We should, shouldn't we? Maybe. Continuing on here, ionic compounds are always made of a metal and a non-metal. So if you see a metal and a non-metal, you know it's ionic. The non-metals steal electrons from the metals, so the non-metals become negative and the metals become positive. The electron orbitals, the clouds, are actually separate from one another here. They're separate from one another. But they do stay close to each other based on the opposite charges. So positive and negative charges attract, right? So we'll get that attraction between the positive ion and the negative ion. These generally have pretty strong attractions to one another, and it takes a lot of energy to melt or boil them. So here down here, it just shows the sodium is giving an electron to chlorine. Now we have a positive sodium cation and a negative chloride anion. Then what holds them together is the fact that one's positive and one's negative. And that is all I have for you guys today. Really simple stuff today. Okay, hopefully it didn't hurt your brain too much. We're not doing this right now. We're going to do this another day. And tomorrow is office hours day. I'm not going to do any lecture. I may post an assignment. So do check in tomorrow and make sure see if there's an assignment or not. Okay. If there's no assignment, then you have no work. It'll be posted before 8 a.m. tomorrow. So make sure you check at class time tomorrow. Just check in. If there's an assignment, do it. If not, you're good to go. That's all I have for you guys today. If you have any questions, feel free to stick around. If not, you're